Functional Point Analysis (FP). Alan Abersh initially developed the functional point analysis in the year 1979 at IBM, and it has been further modified by the International Function Point Users Group IFPUG. FPA, that is functional point analysis, is used to make estimate of the software project, including its testing in terms of functionality or function size of the software product. However, function point analysis may be used for test estimation of the product. So it may be used for the test estimation of the product. The functional size of the product is measured in terms of function pointer, which is a standard of measurement to measure the software application. So the functional size of the product is measured in terms of the function point, which is a standard of measurement to the size of the software application. Objectives of functional point analysis. The basic and primary purpose of functional point analysis is to measure and provide the software application functional size to the client, customer and stakeholder on their request. So the basic and primary purposes. So we say that the basic and primary purpose of the FPA is to measure and provide the software application functional size to the client, customer and the stakeholder on their request. Further, it is used to measure the software project development along with its maintenance consistently throughout the project, irrespective of the tools and technologies. So further, it is used to measure the software project development along with its maintenance consistently throughout the project, irrespective of its tools and technologies. Following are the points regarding the function. Function points of an application is found out by counting the number and types of functions used in the application. So how do you calculate the function point? You calculate it by counting the number of and types of functions which are used in the application. So we calculate it by counting the number and the types of functions. By counting the number and the types of functions which are used in the application. Various functions used in an application can be put under 5 types as shown. So the 5 types are number of external inputs, EI, input screen and tables. Number of external outputs, output screen and reports. Number of external queries, EQ, prompts and interrupts. Number of internal files, ILF, databases and directories. Number of external interfaces, EIF, shared databases and shared routines. So this table is very important. What are asked using this table? Sums or problems are asked with the help of this table. All these parameters are then individually assessed for complexity. The function point analysis functional units are shown in the figure. So you have the functional point analysis which is shown, wherein there is a user is giving some input to the system is giving some output to the user. This is ILF. What did we see? ILF is number of internal files. So this is what inside the system you have number of internal files. That is your databases and directories, and number of external interfaces is present in the other applications. Number of external interfaces. This is the figure. Now FP category size. So the FP categorizes the complexity of the software system and hence can be used to depict the project time and the manpower requirement. The effort required to develop the project depends on what the software does. FP is programming language independent. LOC, we saw LOC was dependent on the language, on the programming language. But FP is independent of the programming language. So this is a point of difference between LOC and FP. One is independent, one is dependent. FP is a method used for data processing systems, business systems like information systems. The 5 parameters mentioned above are also known as the information domain characteristics. So what are the 5 parameters? Number of external inputs, number of external outputs, number of external inquiries, number of internal files, number of external interfaces. They are also called as information domain characteristics. All the parameters mentioned above are assigned some weights that have been experimentally determined and shown in a table. So these are the weights which have been experimentally determined. This table is very important. Why? Because there are weights which are given. So number of external inputs, weight assigned for simple is 3, for average is 4, for complex it is 6. Number of external outputs, simple 4, average 5, complex 7. Number of external inquiries, simple 3, average 4, complex 6. Number of internal files, simple 7, average 10, complex 15. Number of external interfaces, simple 5, average 7 and complex 10. Now how will you remember this? For exam, 3, then 1 you add, you get 4, again 1, again you add 2, you get 6. 4, 1 you add, you get 5, you add 2, you get 7. So this is what? Add 1, add 2. 3, 4, 6, 4, 5 and 7. Then 3, 4, 6 again comes like this. 1 add and then you add 2. Next you have to remember this 7. Here also you will get a 7 diagonally. 10. Diagonal also there is 10, then 15 and 5 are multiple of each other. So the table goes like this: 3, 4, 6, 4, 5, 7, 3, 4, 6, 7, 10, 15, then this 7 comes here, this 10 goes here and 5. So 5, 7, 10. So this you have to remember for the weights of the FP attributes. Next is benefits of functional point analysis. FPA is a tool to determine the size of a purchased application package by counting all functions included in the package. So it will count the size of the package by counting all the functions that are included in the package. It is a tool to help users discover the benefit of an application package to their organization by counting functions that specifically match their requirements. It is a tool to measure the units of software product to support quality and productivity analysis. It is a vehicle to estimate the cost and resources required for software development and maintenance. It is a normalization factor for software comparisons. These are all the benefits of functional point analysis. There are drawbacks, that is disadvantage. So benefits are your advantages of FPA and your drawbacks are the disadvantages of FPA. It requires a subjective evaluation and involves many judgments. Many cost and effort models are based on LOC, so it is necessary to change the function points. Compared to LOC, there are less research data on function points run after creating design spec. With subjective judgment, the accuracy rate of assessment is low. Due to long learning curve, it is not easy to gain proficiency. This is very time consuming method. The following are the metrics which can be calculated using functional point analysis. One, you have errors or killock can be calculated. Then defects or killock, pages of documentation. Errors, productivity is killock upon PM. And pages of documentation can be calculated. So the unit is what? Person month, PM. The functionality complexities are multiplied with the corresponding weights against each function, and the values are added up to determine the unadjusted function points of the subsystems. So we'll see the sums, we'll understand that. Calculation of function point. How to calculate the function point? The function point is calculated with the following formula. Function point equal to count total into 0.65 plus 0.01 into summation of fi. So formula for function point is count total. This formula we have to remember, into 0.65 plus 0.01 into summation of fi. Count total into CAF complexity adjustment factor, where count total is obtained from the above table. CAF is equal to 0.65 plus 0.01 into summation of fi, and summation of fi is the sum of all 14 questionnaires and show the complexity adjustment value or factor CAF, where I ranges from 1 to 14. So here the I ranges from 1 to 14. Usually a student is provided with a value of summation of fi. Also note that summation of fi ranges from 0 to 70, that is 0 greater than equal to summation of fi greater than equal to 70, and CAF ranges from 0.65 to 1.35, because summation of fi, if you put at 0, then CAF is 0.65. Summation of fi, if you put the maximum value, then 0.65 plus 0.01 into 70 gives 1.35. So what is CAF? CAF is this part. Into, if you do count total, you get FP. If you put summation of fi equal to 0, then CAF will be what? 0.65 into, plus 0.01 into summation of fi, but this summation of fi is 0. 0 into anything is 0. So this whole term becomes 0. So you're left with just 0.65. If you put that equal to 70, then you get 0.65 plus 0.01 into 70, which comes out to be 0.65 plus 0.7, that is 1.35. So these are formulas of CAF and FP. What is FP? Functional point analysis. What is CAF? Complexity adjustment factor. So all these things can be calculated based on the FP measures.